We're going to calculate the equation of three planes. One is the equation of a plane that is perpendicular to the normal vector 5i plus 2j plus k and has the point P which coordinates are minus 3, 0, 7. The other is a plane, and this is simpler. These two are the same example, just with different points. I suggest first to try this, has simple coordinates. The plane that contains the point 0, 0, 1, the point 2, 0, 0, and the point 0, 3, 0. And the plane that contains the points 1, 3, 2, 3, minus 1, 6, and 5, 2, 0. If you think you can do it, stop the video now and then continue to see if we have the same result. First, this is very simple. We know that the equation of a plane is a times x minus x naught plus b times y minus y naught plus c times c minus c naught equals 0. This is the equation of the plane that contains the point P, which coordinates are x naught, y naught, c naught, and that is perpendicular to the normal vector ai plus bj plus ck. So perpendicular to this vector. So let's put this now with this information. We have the vector, the normal vector is 5, so we have 5 times the point will be x plus 3 plus b is 2 times y minus 0 is just y plus c. C is where is C? C is 1, so 1 times c minus 7 equals 0. So we have 5x plus 15 plus 2y plus c minus 7 equals 0. We have 5x plus 2y plus c equals 15 minus 7 is 8, so minus 8. This is the equation of the plane that is perpendicular to the normal vector 5i plus 2j plus k and contains the point P minus 3, 0, 7. If I did not do a mistake, arithmetical mistake. Alright, next I will leave it like this in order to check the answer at the end. The other is here. What we know? We have a plane that contains these 3 points. Point, let's say 0, 0, 1. Well, I will just put it like here. This point P. Next point Q. 2, 2, 0, 0. And now let's say here Q. And let's say 0, 3, 0. I don't know, let's put it here. So we have a vector that is a little bit difficult because the plane I cannot put it in 3D, but you have the idea. So here we have 2 vectors. We have 3 points that make 2 vectors. We have this vector and this vector, or you could use this vector and this vector, whatever vectors you want to use. But now we have 2 vectors that lie in the plane, and we want to find the equation of this plane. How do we do that? We, as in this example, we need a normal vector. We have a point, yes, we can pick any of these 3 points, but now our normal vector, how are we going to find it? With the cross product. we have this vector, this vector, this vector, something like this, and the normal to the vector that would be this way in this. I cannot put it very well, but with the cross product we will find the normal vector. So we need to find our normal vector, and we have these two vectors, or you would have chosen this vector and or this vector and this vector, but this vector and this vector. But I will pick this one. So let's calculate the vector PQ and PO. So the vector PQ is equal to let's do this minus this, would be this one would be minus 2, 0, 1, and the vector PO is this minus this would be 0, minus 3, 1. Now the cross product. We know that we can use a determinant that would be PQ cross PO is equal to the determinant I J K minus 2, 0, 1, 0, minus 3, 1. The easiest way to calculate the determinant is if you copy the two columns, the first two columns, so I minus 2, 0, and J 0, minus 3. So then you multiply this, next this, next this. Let's first do that. So we have 0, 0, oops, and 6k, and then minus, now is this with this and this. So this is j would be minus 2j, minus 2j, minus 3i, so minus 3i, plus 0k. So this is the determinant. So the determinant was our normal vector. So we have our normal vector is minus 3i plus 2j plus 6k. So now we have now we need to answer the equation of a plane that is perpendicular to the normal vector and contains whatever point you want to choose. In this example, because I put PQ and OQ, I will pick the P point. So the equation is minus 3 times x, well, minus 0, so x, plus 2j times y minus 0, so y, plus 6k times c minus 1 equals 0. So I have minus 3x plus 2y plus 6c equals 1. Again, if I have not committed any mistake, this would be the equation of the plane that contains these 3 points. And then the last one, that is the same concept. Now here we have our points or our vectors. Now would be PQ are minus 2, 3 minus 1 is 4, 2 minus 6 is minus 4, and the PO is minus 4, 1, 2. Determinant PQ cross PO is equal to the determinant of I, J, K, minus 2, 4, minus 4, minus 4, 1, 2. I copy the first two columns, I, minus 2, minus 4, J, 4, 1. I hope don't to be committing a mistake. So first the determinant would be this, and this. So you have 8I plus 16J plus minus 2K minus then this and this. So it is 2J minus 4I minus 4K. Alright. So, sorry, this was a 4, so it's minus 16. Alright, so I have 8I plus 4I is 12I. Next, 16J plus 16J minus 2J is plus 14J, and then minus 2K is plus 16K. I think I did a silly mistake here. Let me just check the J component. This is 16, and this is minus 4, 1, 2, minus 2, 4, 4 with me. Oh, sorry, here I have a minus. So it was 4 plus, it was saying, no, yes, that's right. J minus 2, this is minus 4 here. So I have minus 4J. Where is my 4J? Yes, sorry, yes, here I have my minus 2J, and so it is plus 2J, so it is 18J. Sorry for that. I knew I was going to commit some silly mistake. Alright, so now we have a normal vector, and we have the point P. So now the equation is 12x minus 1 plus 18 y minus 3 plus 14 plus 14 c minus 2 equals 0. 12x minus 12 plus 18y minus 54 plus 14c minus 28 equals 0. This is 12x plus 18y plus 14c minus 20 minus 12, this is 14, so it's minus 14, so it's equal to 14. I think so. I hope not to have committed a mistake again.